I'm using Sklearn, a powerful Python library for machine learning. Specifically, I'm focusing on ShuffleSplit, a tool that helps me evaluate models by dividing my data into training and testing sets in a clever way. It's all about cross-validation. This is a multiple-choice quiz to test my understanding of how ShuffleSplit works. I have 100 data points and I want to divide them into training and testing sets 5 different times, using 20% for testing each time. The random state ensures that I get the same random splits every time I run the code, making my results reproducible. This tells me the size of the dataset I'm working with. I have a total of 100 samples. I'm setting up ShuffleSplit here. N_splits equals 5 means 5 splits. Means 20% of the data for testing, and random_state equals 42 ensures the same random splits each time. Here, I'm specifying the training size directly. Train_size equals 80 means 80 samples for training, which leaves 20 for testing. 100 total 80 training equals 20 testing, matching my 20% goal. I'm using an integer value for test_size now. Test_size equals 20 means 20 samples for testing, which is exactly 20% of my 100 samples. Here, I'm giving a proportion for the training size. Train_size equals 0.8 equals 80%, leaving the remaining 20% for testing. That's 20 samples again. I'm using Sklearn, a popular Python library for machine learning. Specifically, I'm working with its ShuffleSplit function, which is a clever tool for evaluating models using a technique called cross-validation. Cross-validation helps us understand how well our model generalizes to new, unseen data. ShuffleSplit shuffles the data randomly and splits it into training and testing sets multiple times, giving us a more robust estimate of performance. This is a multiple-choice question designed to test your understanding of how to use ShuffleSplit effectively. Get ready to put your knowledge to the test. I have a dataset of 100 samples and I want to use ShuffleSplit to evaluate a machine learning model. I'll create 5 different training and testing splits, each time using 20% of the data for testing and 80% for training. The random_state is set to 42 to ensure that I get the same random splits each time I run the code, which makes it easier to reproduce my results. I need to identify which of the provided options correctly sets up ShuffleSplit to do this. This option sets up the ShuffleSplit correctly. I specify 5 splits, nsplits equals 5, a test size of 20%, testsize equals 0.2, and a random state of 42, randomstate equals 42. Here, I'm specifying the training size directly as 80 samples. ShuffleSplit is smart enough to figure out that the remaining 20 samples should be used for testing. This is another correct way of setting it up. In this option, I specify the test size as 20 samples. Because I have 100 samples in total, ShuffleSplit understands that this is equivalent to a 20% test size. It's yet another way to arrive at the correct configuration. Similar to option B, I define the training size as 80%, 0.8, and ShuffleSplit automatically calculates the test size as 20%. This works perfectly. I'm working with a dataset that contains 100 data points. These are the different ways to configure the ShuffleSplit function to achieve the desired splitting of my dataset. I'm using scikit-learn's ShuffleSplit, a tool for splitting data into training and testing sets, for cross-validation. Cross-validation helps you evaluate how well your machine learning model generalizes to unseen data. This is a multiple-choice question testing my understanding of how to use ShuffleSplit. This question describes the task. I need to choose the correct ways to set up ShuffleSplit to get 5 splits of my 100 sample dataset, each with 20% of the data held out for testing. Using a random state ensures the same splits are created each time for consistency. This option sets the number of splits to 5, the test size to 20%, 0.2, and the random state to 42 for reproducibility. I think this is correct. Here, I'm setting the training size to 80 samples, out of 100, leaving 20 samples for testing. This is an alternative way to specify the split, and it should also be correct. This sets the test size to 20 samples, out of 100, which is 20%. I believe this is also correct. This option sets the training size to 80%, 0.8, leaving 20% for testing. This is another correct way to define the split. The question involves a dataset that contains 100 data points or samples. ShuffleSplit is the specific cross-validation method from Sklearn being used here. The goal is to create 5 separate test splits of the data, with each test set being 20% of the total dataset size. The whole exercise is about evaluating the performance of a machine learning model using ShuffleSplit for cross-validation. I'm using ShuffleSplit, a tool from Sklearn, for cross-validation. It's like a smart way to split my data into training and testing sets multiple times, ensuring that my model generalizes well. It shuffles the data each time for randomness. This is the core question. I need to find the correct shuffle split settings to split the data 5 times, with 20% held back for testing each time. Using random_state equals 42 ensures that I get the same splits every time I run the code, which is essential for reproducible research. I have a dataset with 100 samples. This is the total amount of data I'm working with. Knowing this is important because it allows me to verify that the number of samples for the test set and train set in each split are correct. This option says, make 5 splits, n_splits equals 5 each time keeping 20% of the data for testing, test_size equals 0.2 and using a random seed of 42, random_state equals 42 to ensure consistent results. This is a perfectly acceptable and common way to set up ShuffleSplit. Here, I'm setting the training data size to 80 samples, train_size equals 80 Because ShuffleSplit knows that the total number of samples is 100, it automatically calculates the test size, 100 minus 80 equals 20, or 20%. So, this achieves the same goal as option A. Here, I specify a test size of 20 samples, test_size equals 20 Since I have 100 samples, 20 samples represent 20% of the data. This directly specifies the test set size and number of samples instead of proportion. This option is similar to option B, except I use a proportion of 0.8, train_size equals 0.8 to represent the training data size, 80%. The test size is automatically calculated as 20%, 1 to 0.8. I'm using fractions instead of numbers here. Again, this perfectly works. I'm using Sklearn's ShuffleSplit for cross-validation. It's a technique that helps you evaluate a machine learning model's performance reliably. It shuffles your data and splits it into training and testing sets multiple times, giving you a more robust idea of how well your model generalizes. I have 100 data points in my dataset, which is my starting material for this machine learning task. The goal is to set up a cross-validation process using the ShuffleSplit function from Sklearn, splitting the data into 5 sets, where 20% of the data is used for testing and the rest for training. The random state of 42 ensures consistent results every time you run it. Here, I'm specifying 5 splits, a test size of 20%, and a random state of 42. This correctly sets up the desired splits. In this case, I'm using. This means 80 samples will be used for training, leaving 20 for testing, since I have a total of 100. The 20% testing proportion is implicitly defined here. Here, I explicitly define the test size as 20 samples, which is 20% of my 100 samples. The number of samples is directly used rather than a proportion. Here, I'm specifying a training size of 80%, indirectly defining the test size to be the remaining 20%. This works just as well. I'm using Sklearn, a popular Python library for machine learning. Specifically, I'm focusing on ShuffleSplit, a tool that helps me split my data into training and testing sets for model evaluation. It's a cross-validation technique that randomly shuffles data and creates multiple train-test splits. That way, I can get a better sense of how well my model generalizes to unseen data. The core problem is to figure out the right way to use ShuffleSplit to prepare data for evaluating a machine learning model. I have a dataset and want to split it into training and testing sets 5 times, 5 splits, with each testing set being 20% of the total data. This ensures a robust evaluation. I have 100 data points that need to be split for training and testing my model. Think of them as individual observations or examples of whatever I am trying to predict. This is the Sklearn function I am using. It's a cross-validation iterator. It helps to create multiple training and testing splits of my dataset. Each split will have a portion for training the model and another for testing it. These are the key settings for ShuffleSplit. N_splits equals 5 means I want 5 different random splits. Test_size equals 0.2 or 20. Which is 20% of 100, sets the size of the testing set to 20% of the total data. Train_size equals 80 or 0.8, which is 80% of 100, is the size of the training set in number of samples, 80, or as proportion, 0.8, of the total data. I'm showing you how to specify the size of the testing or training set in 2 equivalent ways, either in percentage or as a number of samples. The end result I'm aiming for, 5 separate training and testing datasets, generated randomly but reproducibly. This allows for a more robust and less biased evaluation of the model. Each of these 5 splits is used in a round of model training and testing.